Hello everyone, am I audible?
Yes, sir.
Okay, fine.
Yes, sir.
Very good morning to all of you. May I start?
Yes, sir.
Yes, sir.
Fine. So now today we are going to discuss the Fourier series. We have completed unit number 2, complex variable, and this is unit number 3. I know that I think one topic is remaining for civil branch. Okay, as both the branches are combined here. So in this lecture we are going to discuss about the Fourier series. Okay, I will cover that remaining topic for civil branch. I think for mechanical branch I have covered each and everything. Okay, from the second unit. So let us start. So today we are going to discuss about the unit number 3, Fourier series. Is the screen visible?
Yes,
Yes, sir.
Okay, fine. So Fourier series, this is the unit number 3. Now, what is meant by Fourier series? So in this unit, we are going to discuss about the definition of Fourier series. What is this concept actually? Then half range Fourier series means Fourier sine series, Fourier cosine series. Example based on the interval 0 to 2 pi, 0 to L, minus L to L, whatever that. And then after that, complex form of a Fourier series. Example based on that. And then orthogonal and orthonormal concept is also there. So we will discuss all these concepts. So first of all, to understand the definition of the Fourier series, so two basic concepts we will revise so that you can understand the definition of the Fourier series. So first of all is periodic function. Okay, what is meant by periodic function? Is there any idea about this periodic function? What is meant by periodic function? Okay, so let me draw one graph so that you can understand it, how it is actually. So this is very basic graph of sine function. This is like this. I think everybody knows this graph. Am I right?
Yes,
0,
sir.
this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and so on. Okay, so if you observe, forget about these intervals. Okay, we are not interested here in this. Basic idea is what? Suppose if you observe here, so this is here it is pi and here it is 2 pi. Sorry, let me draw it clearly. It is much better like this. Okay, if we extend this line, now this is 0, this is here pi, this is 2 pi, this is here 3 pi, 4 pi, okay, 5 pi, and so on. If you observe what is happening here, see this curve start from here, okay, and curve start from here and ends here. Okay, this is the one rotation, actually one uh, rotation of this curve. Then after this, if it start from here, then again it ends on here. Okay, so if you observe the same part of the curve, same part of the curve repeats after 2 pi to 4 pi. So whatever the portion of the curve it is in the interval 0 to 2 pi, the same part of the curve is there in the 2 pi to 4 pi. Same part of the curve is present into 4 pi to 6 pi. Okay, so what does it mean? The curve is repeating. Curve is repeating after some interval of time. The graph of the function is repeating after some interval of time. So graph is repeating, it means what? the values of the function at that particular point are repeating after some interval of time. Okay, so 0 to 2 pi, same graph, 2 pi to 4 pi, same graph, 4 pi to 6 pi, same graph, and so on. So if we extend this curve before this 0 also, the scenario is same. Okay, so it means what? This is the curve of sine y is equal to sine x. Okay, so it means this curve is repeating after 2 pi interval of time. So therefore we can say that fx is equal to sine x is periodic with period 2 pi. Okay, so this is why, because after 2 pi interval of time the same curve is repeating, the graph is repeating. Okay, so again same thing we can say about fx is equal to cos x. This is periodic with period 2 pi. Okay, so the basic definition of this periodic function is what? Suppose if we have a function fx, a function a function fx is said to be periodic with period t if f of x is same as what? F of x plus t. Okay, so in this case f of x is same as f of x plus 2 pi, like this. F of x is same as f of x plus 2 pi, because see, at x is equal to 0, whatever the value of function is 0. Again at x is equal to 2 pi, value of function is 0. Again at x is equal to 4 pi, the value of function is x plus 4 pi. X plus 2 pi, a value of function is 0. Okay, so values are repeating, so that's why f of x is same as f of x plus 2 pi, and therefore this is a periodic with period 2 pi. Got it? Same thing for cos also. Cos x is also periodic with period 2 pi. So this is the basic definition of periodic function. If fx is same as f of x plus t, then it's said to be periodic with period 2 pi. Okay, so examples we have sin x, cos x are periodic with period 2 pi. Okay, so hope you understand. Now the next concept is what is mean by even and odd function? What is even and odd function? This is very simple concept. What is even and odd function? Suppose if we take fx is equal to, suppose, x square. Okay, and what happen if I replace x is minus x instead of x? Okay, so replace x minus x instead of x. Okay, so replace x by minus x in above function. What I get? See, f of minus x is equal to, so I am replacing x by minus x. Okay, so this is minus of x square. So what is minus of x square?
X square.
Yes, this is x square. And what is x square? X square is nothing but our original function. This is what? Fx. So what I get here, f of minus x is same as f of x. Am I right?
Yes, sir.
Yes, sir.
Okay, fine. So let me explain one more example for you to understand this. Suppose if I take fx is equal to fx is equal to x cube. What I get? So if I replace x by minus x in suppose this is the second, in equation 2, example 2. So what I get? F of minus x, this is equal to minus of x cube. What is minus of x cube?
Minus x.
Minus x cube.
Minus time x cube. Am I right? So this is same as what? Minus as it is. But what is x cube? X cube is nothing but our original function f of x. Am I right?
Yes, sir.
Minus of x.
Okay. So what I get here? F of minus x is equal to what? Minus f of x. See, we have two concepts here. If you observe, f of minus x is equal to minus f of x, and another that we have seen previously, it is f of minus x is equal to plus f of x. Okay. So if we replace x by minus x and function remains unchanged, okay, then function is what? Even. Am I right? Then function is even. So if we replace x by minus x, then function become minus time of f of x, then it is what? Odd. Got it? So now this f of x is equal to x cube is nothing but odd function, because we get my f of minus x is equal to minus f of x, and this is even function. This is very important concept to solve the examples based on the Fourier series. Fx equal to x square. This is what? Even function. Got it? Is there any doubt?
No, sir.
No,
Okay.
sir.
So what is the so see, the basic definitions are if f of minus x is equal to fx, then this imply what? Fx is even function. Got it? And if this is the first concept, second is if f of minus x is same as minus f of x, this then it become what? Fx is odd function.
Odd function.
So there are certain functions, they are neither even nor odd. Okay, for example, let me explain this with the help of example. Suppose if I take fx is equal to x square plus x. Okay, so if I replace x by minus x, what I get? Replace x by minus x. What happened? See, f of minus of x, this is minus x square plus minus of x. I'm replacing x instead of minus x instead of x. Okay. So what I get, this is what is minus x square,
X square. X square minus
square.
x.
and this is minus x. Am I right? Minus plus become minus.
Yes, sir.
This is not our fx. Am I right? This is not equal to fx. Also, it is not equal to what? Minus of fx. Am I right? We cannot take minus sign common and we'll get fx. If I take minus sign common, what I get? Minus of minus x square plus x. Am I right?
Yes, sir.
Yes, sir.
This is not actually minus f of x. Okay, and therefore what I get here? F of x is equal to x square plus x is neither even nor
Nor odd.
If you understood this concept, even and odd function. So some examples I will give. Fx is equal to, suppose if I take sine x. What is this? Even or odd? Fx is equal to cos x. See, this is sine x is odd function because we know that sine of minus x is same as minus sine of x. Am I right?
Yes, sir.
Yes, sir.
So this is odd function. And cos x is nothing but
Even.
even function because
Even
we know
function.
that cos of minus x is same as cos x. This is even function. Think about the other trigonometric ratios. Okay, so how they actually look like. Fine. So this is about the even and odd function. There are some properties of even and odd function related to addition and multiplication. So they are also important. Let me explain them. This is just the revision part. I think you might have seen these concepts in your previous standards, even an odd function. Okay, some properties are there. Let me take that. Properties. First property, let me explain. Suppose if I take any even function and if I add them in any other even function, what I get?
Even.
Even
Even,
function.
yes. Okay. So if I subtract that even function from even function, what I get? Again, a even function.
Even function.
Okay. So keep this in mind. Suppose if I take any even function, okay, sorry, any odd function, and if I take addition of that function with any other odd function, what I get?
Even.
Is it correct?
Even function.
Odd
Suppose
function.
if I take x plus
Even.
x cube, what's
Even
x?
function.
Even. Okay, let us check this. If I replace x by minus x, what I get? F of minus x is equal to minus of x plus minus of x cube. Am I right? Then this is what? Minus x cube. Can take minus common in bracket x plus x cube. And you'll get minus f of x. See, this is odd. Are you getting?
Yes, sir.
This
Yes,
is
sir.
odd. This is also odd. And if we take their addition, I'll get again odd function. Isn't it?
Yes, sir.
So addition and subtraction of two odd function is again odd function. Okay, fine. So I think you are getting confused with addition and multiplication. Let me explain that second rule also. Second is, if I take even function and product with any other even function, what I get? Even into even.
Even.
Even. For example, x square into x raised to 4. I'll get x raised to 6. It is again an even function. Am I right?
Yes, sir.
Okay. Second thing, if I take any odd function and product of that odd function with any other odd function, what I get?
Even.
Even, yes. So these two properties you may get confused here. So if addition and subtraction is there, then odd plus odd is odd minus odd is odd. But in case of multiplication, odd into odd is even, because x into x cube, if I take it, become x raised to 4 and it is even. Get it? This is odd. This is also odd. Am I right or wrong? Okay,
Yes.
fine. Now,
sir.
correct. So if I take any even function and if I multiply it with any other odd function, what I get? Tell me.
Odd.
Odd function.
Odd function, correct. X into x square is x cube. Okay. That's it about even and properties of even and odd functions. So one more property is there. It is Dirichlet's condition. Okay. This is something abstract, but let me explain this in short. Is Dirichlet condition, because our definition is depend on all this concept. Suppose if we have any function defined in some interval, okay, function defined in the interval, suppose that interval is a to b, okay, whatever that interval, and we said that is said to satisfy Dirichlet condition if it satisfies the following conditions. If it satisfies following conditions. What are that conditions? Okay, so the first condition is what? First condition is fx is periodic. We have seen that what is by periodic function. Fx is periodic. Second, fx and its integrals are finite and single value. Okay, so it means what? It is integrable. Fx is integrable. We know how to find out the integral. Fx and its integral are finite. Okay, so they should be finite. If they are not defined, fx is not defined, then it doesn't satisfy the Dirichlet condition. Not defined means, suppose if I take fx is equal to like this, fx is equal to uh, um, x square upon x minus 1. Okay, and if I take the interval 0 to 2, now in this interval this function is not defined. How? Because if I take x is equal to 1, what I get? 1 minus 1, 0. Denominator becomes 0. Anything upon 0 is infinity, not defined. So this fx is not defined in this interval. Got it? So like this, its integration is also not defined. Fx is not defined, integral is not defined in this interval. So this is the basic concept. So fx and its integral are finite. Okay. It should not be, if it is not defined, then Dirichlet condition is not satisfied. And fx is piecewise continuous. This is also interesting. Third one, fx is piecewise continuous. In AB. What does it mean by piecewise continuous? If we see the graph of sin x, see, if we see the graph of sin x, it is continuous graph. It doesn't have a break. If we see this interval 0 to 4 pi, like this interval, it doesn't have break and doesn't have any uh, what I say means like this. Suppose if I take this function, let me give another example. Suppose if I take fx is equal to mod x, okay, or if I take step function, okay, step function. If I take the graph of step function, it is like this. This is the graph of step function. Okay, I think you have seen this step function in Laplace transform. You have seen the Laplace transform of step function also, Fourier transform of step function also. Okay, so this is the graph of step function. See, if we define the interval 0 to 10, so in this interval this function is not piecewise continuous. Why? Because there is a gap. So there is a break here, there is a break here, there is a break here. Okay, so that's why this function is not piecewise continuous. So what is piecewise continuous? We are dividing this whole interval into small pieces. Okay, and in every piece, if the function is continuous, then we can say that it is a piecewise continuous. Okay, if we see the e raised to x, this is the graph of function y is equal to e raised to x. See, this function is smooth curve. It doesn't have break, doesn't have any bend. Okay, so if we define the interval 0 to 10, divide this interval into finite sub intervals, छोटे छोटे pieces मध्ये convert केला आपण. Okay, and see, if you observe, in every piece the function is again continuous. It doesn't have any break or bend in that interval, so it is piecewise continuous. So this is the basic idea about this concept. I'm not going in detail about this. Fx is piecewise continuous in AB, and fx has finite number of maxima and minima. Fx has finite number of maxima and minima. What is the maxima and minima? Local maximum, local minimum. So these are the concept I think you have seen your previous courses. Okay. So let me shortly explain this. Suppose if this is the function, okay, like this. This is the graph of the function. So if you observe, so this function has some finite maximas and some finite minimas. Okay, it is like this. So this here, this one, this one, this one, this one, this one. These are the maximas. These are the finite number of maximas. Okay, and these are minimas, minimum values. These are actually a local minimums, local minima, local maxima. This is the concept. Okay, a minimum values of the function at particular point. Okay, so what is the maximum value of the function at particular point? What is the minimum value of the function for particular point? So this is nothing but the local maxima and local minima. So if the function has a finite number of local maxima and minima, then it is also the condition for the function to be satisfy the Dirichlet condition. So if these four conditions are satisfied by the given function, then it is said to be satisfy the Dirichlet condition. Okay, so don't break your head with all these conditions if you haven't understood this. Okay, because we are not using these conditions for solving the examples. We haven't we will not checking actually these conditions whether the given function satisfy the Dirichlet condition or not. Whatever the example we have in the exam, if the what are the function actually we have in the example, it always satisfy the Dirichlet condition. They are asking to find out the Fourier series for this function. So it is obvious that that function is satisfied with the Dirichlet condition. Fine. So let us move forward for the definition of the Fourier series. Definition. This is very important definition. Suppose if we have the function fx, which is periodic in the period with period 12, defined in some interval. So we just take a common interval c to c plus 12. Okay. Let fx be a periodic function with period 12, whatever that period. Okay, so it may be 2 pi, it may be pi, whatever that. Okay, so because tan and cot are the periodic with period pi. Okay, so in that case, what is your L? L is nothing but pi by 2, like that. So we will find this while solving the examples. Suppose if fx is periodic function with period 12, defined in the interval we take some common interval in the interval c to c plus 12, whatever this c to c plus 12. Sometimes c might be 0, L might be pi, then the interval becomes 0 to 2 pi. Okay, and satisfy Dirichlet condition. That's why I have taken this condition. Okay, because if I directly take this definition, so you may get confused what is mean by Dirichlet condition, what is the periodic function and all that things. Okay, so and it satisfies the Dirichlet condition, then Fourier series expansion. This is nothing but the series expansion. You have seen the Taylor series expansion. Maclaurin's maybe Maclaurin series expansion. I don't know whether you have seen the Maclaurin series expansion or not, but you have seen the Taylor series expansion. So what Taylor series expansion gives? It gives the series expansion in terms of in the power of x for the given function fx. So same thing is here. With the help of Fourier series, we can also find out the series expansion of given function fx. For example, what is the series of cos x, sin x? What is the series of cos x? What is the series of e raised to x? It is 1 plus x square by 2 factorial plus x cube by 3 factorial plus so on. And from this, we can also take this series of sin x and cos x. Okay, so all the even powers are there in the cos, or all the odd powers are there in the sin. So this is x minus x cube upon 3 factorial plus x is to 5 upon 5 factorial and so on. This is 1 minus x square upon 2 factorial plus x raised to 4 upon 4 factorial, so on. These are the series expansion of sine, cos, e raised to x, whatever. You can also find out the series expansion of log function and all that things. Okay. So how to find out these type of series expansion? We have different kinds of method, and Fourier series is one of them. Okay. And this series, this concept is discovered by Joseph Fourier. Okay, so one of the great mathematician who find out the series expansion, or to expand the given function in the terms of power of x. Okay, so then Fourier series expansion of fx, then fx can be expressed as, then fx can be expressed as, see how it is, fx is equal to f of x is equal to a naught upon 2. What is this a naught? I just come to later. Summation of an cos of n pi x upon l plus bn sine of n pi x upon l, n from 1 to infinity. This is the definition of the Fourier series, this expansion. So here, so what are these a naught, an, and bn? Where a naught, an, and bn are called Fourier constants or Fourier coefficients. Fourier constants, or they may also Fourier coefficients. How to find them? Because this is the main task in this type of examples, to find out a naught, an, and bn. Okay, sometime a naught, an becomes 0, sometime a naught, an becomes 0, sometime bn becomes 0. So there are some certain conditions, actually in that special conditions they may be 0. Okay, we will discuss them with the help of table. Once if you learn that particular table, so whatever the example they are given us, we can able to solve that. Okay, so how to find out this Fourier constant? So where a naught is, what is c? A naught is 1 upon l integration c to c plus 12 f of x into dx. Of course, this integration is very important in this case. Then what is an? An is nothing but 1 upon l integration c to c plus 12 fx into cos of n pi x upon l into dx. Okay, and what is a bn? Bn is 1 upon l c to c plus 12 into fx sine of n pi x upon l dx. That's it. This is the definition of Fourier series. Okay, so we have to, whatever the example they will ask, just write down the series expansion of fx a naught upon 2 plus summation n cos n pi x upon l plus bn sin n pi x upon l, and then after that, what are a naught, an, and bn? So these are the result to find out the a naught, an, and bn. Of course, the interval whatever given in the example plays very important role here. So we have to think about that. We have to replace the value of c, we have to replace the value of l over there, and then check what are the limits exactly for this integral. What is the value of l? Because 1 upon l is there, isn't it? So is there any doubt to this point? Let me know so that I can again explain it. Are you getting all these concepts up to this point? Am I audible?
Yes.
Okay. Fine. So now let us move forward with actually what is the table to solve the example. Okay, so let me explain that table first. So the first thing is name of the series. Name of the series. Then interval is there again, and then Fourier constant and expression for the Fourier series. Fourier constant and expression. So I will specify each and every interval, what is the possible interval they may give us, and what should be the Fourier constant and expression for the Fourier series for that particular function in the given interval. Okay, suppose basic definition that we have seen, let us take that. Okay, so suppose the name of the series is Fourier series. Just a minute. So the name of the series is Fourier series. Then suppose interval is C to C plus 12. This is the definition. I'm repeating that definition. Okay. So we know that what is AFX? What is A naught? A naught, it is 1 upon L that we have seen. C to C plus 12 Fx into dx. This is our A naught. Okay, so what is an? An is 1 upon L integration C to C plus 12 fx into cos of n pi x upon L dx. And what is Bn? Bn is 1 upon L integration C to C plus 12 fx into sine n pi x upon L dx. This is the basic definition. And what is the Fourier series expansion of fx? This is a naught upon 2 plus summation an cos n pi x upon L plus bn sine n pi x upon L. Isn't it? So this is the definition. This is the basic definition that we have seen. Now with the help of this, if the interval is now 0 to 12, then what will happen? Okay, see, if the interval is 0 to 12, then what will happen? Let us see. Extend this line. Extend this line. Again, the name of the series is Fourier series, as that of previous. Second, Fourier series. Suppose the interval is 0 to 2 pi. What I have, 0 to 12. What I have done here, I have taken C is equal to 0. Okay, so whatever the previous formula that we have, instead of C, put 0. So what will happen here? 0 to, what is 0 to? C is 0. 0 to 12. Same, 0 to 12 and 0 to 12. Everywhere that's 0 to 12. And A naught, A and B and the limits are only changing. Okay, everything is same. So what is your A naught? A naught is simply 1 upon L integration 0 to 12 fx into dx. Then what is bn? An 1 upon
Hello.
L. Yes, what is happening?
सर ते एलच्या जागेवर 2L येईल ना एलच्या जागेवर 2L येईल ना
Okay, denominator ला. Yes. Where 12? Here.
हाँ सर ते
No, it is L. It is L, not 2L. Okay, because we are taking 0 to 2L. Interval is C to C plus 12. If I am taking 0 to L, okay, then it becomes 12 here. Then it is 12 here. Hello, Lakshan?
नाही सर.
नाही कळालं.
No sir.
Okay. So see, if you observe the definition, so what is the definition? If we have a function fx which is periodic in this with the period 2L, okay. So this is very important thing here. Period is 2L, okay, and define in the interval C to C plus 12. This is the interval. Then the series expansion of this is this, and what is A naught? A naught is 1 upon L C to C plus. Have you understood this definition or तर तुला इथे पाहिजे 12 इथे इथे पण डाउट आहे इथे 12 पाहिजे असं.
No sir इथे नाही.
It is correct na? Is there any doubt in the definition?
No.
No. Then same definition we have applied here. We haven't changed anything. See, we haven't changed anything in the first content. Okay, we have written H and everything as it is. So I think you have a doubt in this. Am I right? इथे 12 पाहिजे.
Yes sir.
No, don't think about that. What we have done, we have just taking C is equal to 0. इथे बघा इथे 0 घेतलाय आपण. C is equal to 0. If I take C is equal to 0, what I get? 0 less than x less than equal to 0 plus 2, 0 plus 12 is nothing but 12 only. Am I right?
Yes sir.
And then accordingly we change the limits of the integrals. So this C to C plus 12. Okay, see, observe previously it is what? It is C to C plus 12. Is it right? C to C plus 12. What I am doing? I am just replacing C by 0. So what I get? C becomes 0. 0 to 0 plus 12. Okay, and what is 0 plus 0 plus 12? It is 0 to 12. 0 to 12. And this is as it is. 1 upon L. There is no involvement of C here. Okay, so that's why it is same. This 1 upon L is same. There is no change at all. Are you getting?
Yes sir.
Okay, so that will be changed in the Fourier series in case of half range Fourier and half range Fourier sine series and half range Fourier cosine series. Okay, we will discuss about that. Don't worry. This is 0 to 12 fx into dx. Now an is 1 upon L. Again it is 0 to 12 fx into cos of n pi x upon L dx. Everything is same. Bn is equal to 1 upon L 0 to 12 fx into sine of n pi x upon L dx. Okay. And what is fx? Series expansion. Fx is what? A naught upon 2. Everything is same. Plus an sine cos n pi x upon L plus bn sine n pi x upon L. And from 1 to infinity. Is there any doubt?
No sir.
Okay, fine. Now next is what? If I change the interval, what will happen? Okay, again the name of series is Fourier series. Just a minute. Nice. Suppose if I change the interval from minus L to L, then what happens? And so in this interval, suppose fx is neither even nor odd. fx is neither even nor odd. We have seen the example how the function is neither even nor odd. Am I right? So suppose if the function is neither even nor odd and if the interval is minus L to L, then what is your A naught? Just change the limits of the integrations. A naught is equal to integration 1 upon L. Just a minute. What is A naught? This is 1 upon L integration minus L to L f of x into dx. What is an? It is 1 upon L integration minus L to L f of x into, sorry, f of x into cos of, it is n pi x upon L dx. Okay, and then dn is equal to 1 upon L integration minus L to L f of x into sine n pi x upon L into dx. फक्त इंटरवल लिमिट्स चेंज होती ना, लक्षात घ्या. And fx is again same. Fx is a naught upon 2 plus summation an cos of n pi x upon L plus bn sine of n pi x upon L, and from 1 to infinity. That's it. So just keep in mind that function is neither even nor odd. Okay, that's why this is happening. But if the function is even, suddenly the things are changing. Okay, how they are changing, let us see. So if you understand this table, you can able to solve each and every example based on this. Okay, so this is very simple concept. Just you have to remember all the results, depend on their interval, whatever it is given in the example. Okay, so let us see Fourier series. Again name Fourier series. Suppose interval is minus L to L, and see what is happening here. Suppose the function is even, fx is even, then what happening? Okay, if the function is even, then your interval becomes 0 to 2L, 0 to, instead of minus L to, suppose the interval is minus L to L and function is even, that becomes 0 to L. Okay, and once the interval becomes 0 to L, then function is what? Then Fourier series is nothing but called as a half range cosine series. This is called as a half range Fourier cosine series. This is, see, this is happening only when the interval is minus L to L and fx is even. Okay, so let me explain this with the help of example. Suppose if we have the interval, if we have the function fx is equal to x sine x square. Suppose fx is equal to sine square x in the interval minus pi to pi. Okay, so we know that sine x is odd function, but sine square x, it is even function. Am I right? And interval
Yes.
is what? Minus pi to pi. So therefore what? Fx is even in minus pi to pi. Am I right? So that interval become what? 0 to pi. And we have to find the half range cosine series for this. म्हणजे तिथे आता बघा फंक्शन इवन असलं आणि इंटरवल तुमचा मायनस एल टू एल असला तर काय झिरो होत आहे ते आय विल गिव्ह यू. ओके, सो नाव इन दिस केस your a naught is, observe it carefully. What is a naught? A naught is equal to 2 upon L. See this, results are changing. This is 2 upon L. Okay, integration 0 to L fx into dx. What is an? An is 2 upon L integration 0 to L fx into cos n pi x upon L dx. Am I right? And interesting fact about this half range cosine series is what? Bn is 0. There is no need to find out Bn. Are you getting? Okay. And what is your fx? Series expansion of this fx is a naught upon 2 plus summation an cos of n pi x upon L. That's it. N from 1 to infinity. There is no need to take Bn because Bn is 0. Straightforward लक्षात ठेवायचं. If the interval is minus and 12 and if function is even, you know how to check whether function is even or odd. We have seen that. Okay. So if the interval is minus and 12, function is even, then there is no need to find out Bn. Bn is automatically 0. You may write directly Bn is 0. Just only find out a naught and an and substitute that in this region. Getting? So no?
Yes, sir.
Okay, fine. Now the same case is here. So in the opposite sense, if the fx is odd, then what will be 0 and what will be non-zero? Okay, so let us see that. So again, the series is Fourier series. Suppose interval is minus L to L, and if fx is odd, okay, then what becomes? The interval becomes 0 to L. Consider that interval as 0 to L. Okay, and the Fourier series is what? Half range sine series. And in this case, see, this is very important. In this case, your a naught is 0 and an is also 0. There is no need to find a naught and an. Okay, and what is bn? Bn is 2 upon L integration 0 to L fx into sine of n pi x upon L dx. And what is the series expansion of fx? This is a naught is 0, an is 0. There is no need to take, only bn sine of n pi x upon L, n from 1 to infinity. It means if interval is minus L to L, function is odd, then a naught and an are automatically 0. Only need to find out what? Bn. Got it? Is there any doubt?
No,
Now, so same things are happening if the interval is 0 to pi, 0 to 2 pi. So instead of L, if I repeat, if I replace pi, then all the results you may write. Okay, so replace, this is the take home from you. Okay, so replace L by pi in all above. Okay, and check what are the results. Okay, for example, suppose if I take this last result, suppose the interval is minus pi to pi. Okay, so minus pi is less than x is less than pi, so it become what? 0 to pi. Am I right? And what is your a naught here? A naught is 0. B naught, sorry, an is also 0. An is also 0. And what is bn? Bn is simply 2 upon pi integration 0 to pi f of x into sine of n pi x upon pi. L is nothing but pi dx. So this pi get cancelled here. Okay. And what is the result actually? It is 2 upon pi integration 0 to pi f of x into sine of nx dx. Got it? Isn't it? So
yes, sir.
this is actually the formula. So if we replace L by pi, in every result you may get sin nx or cos nx. Okay, sin n pi x upon L राहणार नाहीये तिथे, because if I replace L by pi, so that pi get cancelled with the numerator pi. Okay, in each and every result, whatever we have written over here, so that pi get cancelled. Okay, the limits are changing. We are replacing L by pi. So in each and every result that we have written over here, so replace L by pi and rewrite all the results. Okay, so I will share you this PDF. Okay, or I will give you the link how to download the notes. I have uploaded on some website. Okay, so that you can download it from there and access it. Okay, so notes I will provide you. Don't worry about this. Is there any doubt? Yes.
No, sir.
Okay, fine. So these are all the results related to the Fourier series. Okay, let us see some common formulas that we are going to use to solve the examples. First is integration e raised to ax into sine of bx into dx. What is this integration? This is the direct integral actually. Okay, so just keep this in mind. We are using this very frequently while solving the examples. This is e raised to ax. This is e raised to x divided by a square plus b square. See, this is your a and this is your b. Okay, in bracket a sine of bx minus b cos of bx. Okay, this is the formula. This is very standard formula actually. Plus c is there, of course. I think you have seen this formula in class standard. You have seen the proof of this formula also. I'm not going in detail about the proof. Okay, we are using directly as it is. E raised to x into cos of bx. Instead of sine, if there is cos, then what is the formula? So this is e raised to x as it is divided by a square plus b square in bracket a cos of bx plus b sine of bx plus c. Of course, that plus c would not be there because we have a limit of integration. We have a limit. We have the integral which contains the limit. So that's why there is no need to take the constant of integration. As here there are no limits, that's why I have taken the constant of integration. So one more thing is very important. So from the definite integral, suppose we have the integral f minus a to a f of x into dx. Okay, so this become what? 2 time integration 0 to a. Okay, fx into dx if the function is even, fx is even. Okay, and it is directly 0
Odd function.
if fx is odd. Okay, so if you know this result, you automatically understood why I'm taking this 2 upon L here and why Bn is 0 here. Okay, so let me explain it shortly. So why Bn is 0 here? Suppose if I write the formula for Bn, this is fx into what is that? It is sine of n pi x upon L dx. Okay, it is minus L to L. See, fx is what? Fx is even and sin x what? Odd. What is even into odd? Odd function. Am I right?
Yes.
Even into odd is
Yes.
odd. Okay, so minus L to L of odd function. See this formula. If function is odd, the answer of this is what? Directly 0. Answer of this is what? Directly 0. So same thing is happening here. Okay, because in this case, where it is. Yes. In this case, total function become odd. This total function become odd. Okay, and integration of odd function in the interval minus L to L, it is 0. Okay, that's why Bn is 0 here. And what about a naught and an? As fx is even, in the interval minus L to L. See here, as fx is even in the interval minus L to L, then it is 2 times integration from 0 to a, 0 to L. See, this is 2 times 0 to a fx dx. So we have integration a naught is equal to 1 upon L integration minus L to L fx dx. But fx is even. Therefore, with the help of this integral, it become what? 1 upon L as it is. It is 2 into 0 to L fx dx. Am I right? And that's why this become 2 upon L integration 0 to L fx into dx. Got it? Is there any doubt?
No,
So
sir.
this is how that results come. Okay. That's why I haven't explained that over there. Okay. Now, the third result is related to this. This is also very important. What is sine n pi? Sine n pi is 0 for all n, whatever the value of n. Sine n pi is always 0. What is the value of cos n pi? Cos n pi is
-1.
plus 1 if n is even. Am I right? And this is minus 1 if n is odd. Got it? It means cos of 2 pi, cos of 4 pi, so on. They are all plus 1. And if I write cos of pi, cos of 3 pi, and so on, these all are what? Minus 1. Is there any doubt? Yes?
No, sir.
No,
Okay.
sir.
So fine, this is about the basics and formulas related to Fourier series. Okay. And now let us move forward for the examples based on this. Okay. I will take only one example today. And then we will discuss about the remaining examples. Okay. So that you can understand how actually the things, how actually we are applying the formulas over here. Okay. So let us see the example one. So it says that find half range cosine series for fx is equal to sine square x in the interval 0 to pi. Okay, one more thing, if they are asking to find out the cosine series, half range series, okay, there is no need to check whether the function is even or odd, whatever the interval which is given, okay, don't think about that. Directly find out the half range cosine series. Okay, now let us come to the table where actually the half range Fourier cosine series. Okay, see, this is the half range Fourier cosine series. So what is my interval? So this is 0 to pi. 0 to L is given actually in the example. So this is my interval 0 to pi. So what is the value of L? L is nothing but pi. We
Pi.
have to replace pi instead of L. Am I right?
Yes, sir.
Yes.
Okay. So this is the function fx is equal to a naught upon 2 plus summation n is equal to 1 to infinity an cos n pi x upon L, and bn is 0 here. There is no need to find out bn. Am I right?
Yes, sir.
Okay. So therefore, half range Fourier cosine series is given by
सर स्क्रीन दिसत नाही.
Yes. There's some differences. I think it is visible. Am I right?
Yes, sir.
Okay, fine. Now,
Yes, sir.
see what is happening here. Half range Fourier cosine series is given by half range cosine series is given by fx is equal to what? Fx is equal to a naught upon 2 plus summation an cos n pi x upon L. Am I right? And from 1 to infinity. Is it right? So this is the expression for half range cosine series. See here. This is the half range Fourier cosine series. Am I right?
Yes, sir.
That I have written as it is. And now, so what is my and L here? L is nothing but pi.
Pi.
Instead of L, I am replacing pi. So what is happening here? It is pi. So this pi get cancelled, and what I get? It is only nx. Am I right?
Yes, sir.
It is only nx. An cos nx. What is a naught? A naught is equal to what? 1 upon L. Am I right? So it is, so this is, what is that A naught? A naught is 2 upon L. See, this is 2 upon L. Half range Fourier cosine series. This is 2 upon L, 0 to L fx dx. Instead of L, there is what? Pi. Okay. So write it here. So A naught is what? 2 upon pi. Am I right? Integration 0 to pi fx into dx. Correct है? समझ ले?
Yes, sir.
Replace fx. What is fx? Fx is sine square x. It is given actually in the example. 2 upon pi 0 to pi fx is nothing but sine square x into dx. Now let us find out the integration of this sine square x. So we don't have direct formula for that. Better way, we know that cos of 2 theta is nothing but, I think it is 1 minus 2 sine square theta. Am I right? Trigonometryचा formula आहे. आठवतोय?
Yes, sir.
Now we want sine square theta. So this is sine square theta is simply 1 minus cos of 2 theta divided by 2. Yes, we can replace this sine square theta by this term. So this is equal to 2 upon pi integration 0 to pi. Then it is 1 minus cos of 2x divided by 2 into dx. Am I right? Is there any doubt? How I
no,
have
sir.
written this? I have used this formula over here. Instead of sine square x, I have replaced 1 minus cos 2x upon 2. So if I take this 2 outside the integral because it is constant, so this 2 and 2 become cancelled. Only 1 upon pi is there outside. 0 to pi. Then 1 minus cos of 2x into dx is there. Am I right? Yes or no?
Yes, sir.
Okay. If you have a doubt, please ask me because these are the integrals concept. Now, what is integrate this? What is the integration of 1? And directly taking the integration. What is the integration of 1 with respect to x?
X.
X. Minus. What is the integration of cos 2x?
Sine 2x
Sine
upon
2x divided by 2.
Yes, very good. It is sine of 2x divided by 2. Limits runs from 0 to pi. Now apply the limits. For upper limit, it is 1 upon pi as it is. For upper limit, replace x instead of pi instead of x. So this is pi minus sine of 2 pi divided by 2. Am I right? Upper limit minus lower limit. For lower limit, x is 0 and sine 0 is again 0. So therefore, this is 0. For lower limit, everything becomes 0. And now, as we know, we have seen that sine n pi is 0 for all n. Okay, so this term become automatically 0. So this is nothing but 1 upon pi into only pi is there. So again, that pi get cancelled. And finally, what I get? A naught is equal to 1. Is it right?
Yes, sir.
A naught is what? 1. Okay. So first Fourier constant we have now. Now let us find out an. Okay. So what is an? What is the formula for an? An is equal to again 2 upon pi. Am I right? Integration 0 to pi fx into cos of nx dx. Correct?
Yes,
Yes,
sir.
sir.
Okay. Instead of L, we have taken pi. So this is 2 upon pi. Integration 0 to pi. Replace fx. It is simply your sine square x. Sine square x. And this is cos of nx dx. We don't have the integral for this. Again, we are not able to use the u into v result. Okay, better way we have the trigonometry always help us. So we again convert this sine square x in that with the help of that previous formula we have used 2 upon pi 0 to pi 1 minus cos of 2x divided by 2 into cos of nx, because we have the formula for sine a cos a cos b. Okay, that we will use. Now that 2 is outside and get cancelled with outside 2. So 1 upon pi, see 0 to pi. Only thing is here. 1 minus cos of 2x. Observe this integral carefully. I'm solving this. If you have any doubt in this, let me know. This is cos nx dx. Take the multiplication. I'm separating the two integrals. In the first integral 0 to pi, 1 into cos nx is there. It is cos nx dx minus in the second integral 0 to pi. This is cos of 2x into cos of nx dx, like this. Get it? So now,
Sir, can you repeat?
yes.
Can you repeat this step?
Okay, I will repeat it. So I am taking the multiplication. See what is happening inside the integral. The previous step for this step, it is 1 into cos nx is simply cos nx minus cos 2x into cos nx dx. And I am separating the two integrals. So in the first integral only cos nx minus in the second integral this term. Got it?
Yes, sir.
Fine. Now take the integrations. For the first, it is very simple. 1 upon pi as it is. What is the first integral? Okay, so keep this as it is for a while. 0 to pi cos of nx into dx. What about this integral? Minus. What about this integral?
Cos of 2x plus nx
This is
minus
nothing
sine
but
of
what? Sine cos a cos b. So what is cos a plus b? It is nothing but cos a cos b. What is that? Minus sine a sine b. Am I
sine.
right? And what is
Yes,
cos
sir.
a minus b? This is simply cos a cos b plus
Yes.
sine a sine b. Am I right? So if we add these two, what I get?
1 by 2 cos of
Cancel
a
this.
plus b.
So this is cos
1 by
a plus b plus cos a minus b. This is equal to 2 times cos a cos b. Am I right? Shift
yes,
this
sir.
here. So cos a cos b is equal to 1 by 2 cos a plus b plus cos a minus b. Am I right? So
Yes, sir.
Yes.
same formula I am using over here. So what is my a? A is nothing but 2x. What is my b? B is nothing but nx. So what is there inside the integral? 0 to pi cos of 2 plus n into x minus cos of 2 minus n into x. Am I right? Dx.
Yes, sir. 1/2.
1/2.
1 by 2 is there, of course. Sorry for this. Right. So, suppose if 2 is n is not equal to 2 here. Okay, think about this. I'm writing this. You have just homework for this. If it is 0, if n is not equal to 2. Okay, this is homework for you. Let me know in the next lecture how this becomes 0 if n is not equal to 2. Okay, so if I take n is equal to anything instead of 2, this becomes 0. This an becomes 0. Means a1, a3, a4, a5 all are become 0. Got it? This means what? A1 is equal to A3 is equal to A4 is equal to so on, all are 0. So if I take n is equal to 1, what is happening? Observe it. Is it 0 or not? If I take n is equal to 3, what is happening? Observe it, whether check it, whether it is 0 or not. Okay, so check this for all n. Okay, if n is not equal to 2, take some finite values or check for these three values, n is equal to 1, n is equal to 3, and n is equal to 4. Check whether it becomes 0 or not. Okay, so for n is not equal to 2, an is 0. For it is non-zero, for n is equal to 2, what is happening? For n is equal to 2, a2 is equal to, put 2 instead of n. So it become what? It become 1 upon pi in the bracket 0 to pi cos of 2x dx minus 1 by 2 integration 0 to pi. This is cos of 4x minus, it becomes 0. If I take n is equal to 2, it is 0. Am I right? So 2 minus 2 is 0. Cos 0 is 1. Am I right?
Yes, sir.
This is 1. Cos 0 is 1 into dx. Okay. And now what I get simply here is or we can substitute. There is no need to substitute this value over here. We can directly substitute in this formula. N is equal to, we'll get cos 2x over here. So this is much more complicated. Okay, so just don't do that. So I'm just replacing this n is equal to 2 in the previous result so that it becomes easier. Neat. I'm getting. For n is equal to see what is happening over here. A2 is equal to, I'm replacing this n is equal to in this formula. In this formula, 2 upon pi 0 to pi. This is 2 upon pi integration 0 to pi. It is 1 minus cos of 2x divided by 2. Then it is cos of nx. Nx is nothing but 2x dx. Am I right? I'm just replacing n is equal to 2 here. N is equal to 2 here. Okay, the 2 get cancelled. Then it is nothing but take the integration also. This is 2 get cancelled, only 1 upon pi integration 0 to pi Then again use that result, previous result over here. I get by 2 1 minus cos of 2x into cos of 2x outside dx. Take the multiplication and separate the integrals. 1 upon pi integration 0 to pi. 1 into cos 2x is cos 2x. Am I right? Dx minus integration 0 to pi cos of 2x into cos of 2x dx. Okay. Then this is nothing but 1 upon pi integration. What is the integration of this? Is the integration of cos? Okay, just a minute. 1 upon pi cos of 2x dx. What is cos 2x? It is minus integration 0 to pi cos square 2x. Am I right? Dx.
Yes, sir.
Okay, and let me explain this formula. What is cos of 2 theta? 2 cos square theta minus 1. Am I right? There are 3 to 4 formulas for cos of 2 theta. So this is
Yes,
2
sir.
cos square theta minus 1. Am I right or wrong?
Yes, sir.
Yes. Okay. This is one more formula. Previously, we have used this where it is cos 2 theta is equal to 1 minus 2 sin square theta. This is one more formula for cos 2 theta. Revise it from trigonometry. Okay. Now, from this, what is this cos? This one is minus here. If I shift it into this side, what I get 1 plus cos 2 theta is equal to 2 cos square theta. Am I right?
Yes, sir.
And shift this 2 into the denominator. So it becomes 1 plus cos of 2 theta divided by 2. This is equal to cos square theta. Is it right?
Yes, sir.
And replace theta by 2x. Because we want the value of cos square to 2x. Okay. So what is it? This imply म्हणजे जिथे theta आहे तिथे 2x टाकायचं आहे आपल्याला. 1 plus cos of what is here?
4x.
4x divided by 2 is equal to cos square 2x. Is it right?
Yes, sir.
So instead of cos square 2x, we can write what?
1 plus
Plus cos
4x.
4x upon 2. Okay. So let me change that integral. So it becomes suppose this is 1 upon pi. What is the integration of this? This is sine. Okay, we write one more term. 0 to pi cos of 2x into dx minus integration 0 to pi. It is 1 plus cos of 4x divided by 2 into dx. Bracket complete. Now apply the integrals. 1 upon pi. What is integration of cos 2x? It is simply sine
Sin
of
2x
2x
upon 2.
divided by 2. Correct. Minus 1 by 2 as it is. And integration of 1 is x. So this is, I think, minus x by 2. Am I right?
Yes, sir.
Yes, sir.
And this is minus plus become minus. What is the integration of cos 4x?
Sin 4x upon 4.
4. And already 2 is there. So this is nothing but sine 4x
Sin 4x.
divided by 8. Once from 0 to pi. And if we apply the limits for lower limit, all r become 0 because sine 0 is 0, x0 takla 0 is sine 0 is 0. For lower limit, everything becomes 0. Now for upper limit, what is happening? See, sine 2 pi is 0 minus pi by 2, x is pi minus 0 minus for lower limit 0 minus 0 minus 0. Okay, check this. Sine n pi is 0. Sine n pi is 0 for all n. Okay, and what is happening only here? It is, I think, minus 1 by 2. Correct? Eh? A2 is nothing but
Yes.
minus 1 by 2. Okay, and therefore, so what is the series expansion? So therefore, fx is equal to a naught upon 2 plus summation an cos nx. Okay, n from 1 to infinity. As we know, for n is equal to 2 only, so this is a naught upon 2 plus a2 cos of 2x. Am I right? Why? Because a1 is equal to a3 is equal to a4 are all zeros. बरोबर ना? ही जर series expand केली तुम्ही तर काय मिळेल? a1 cos of x plus a2 cos of 2x plus a3 cos of 3x plus so on. If I expand this series, for n is equal to 1 this, for n is equal to 2 this, for n is equal to 3 this. But we know this is 0, a1 is 0, a3 is also 0, all terms are 0, only a2 cos 2x is there, and substitute the values of a naught and a2. What is a naught?
1.
So this is nothing but fx is sine square x. A naught is 1 divided by 2 plus what is a2?
Minus 1 by 2.
Minus 1 by 2. Okay, so this is simply what? This is minus 1 by 2 into cos of 2x. That's it. This is my answer to this question. Are you getting this?
Yes, sir.
Okay. So just try to solve it. Practice it. Okay. So I know this is very lengthy example, but we don't have any choice. I have intentionally add some extra steps to understand the integral. Okay. I think there is no need to just add these all terms. But I know that you have some difficulties in integral, so that's why I have added some more extra terms. Okay. Right. So this is about the Fourier series example. So try to solve this. I will do one example for homework. Okay, so this is homework. Just write down this example. Find Fourier series to represent the function. This is very simple. Find Fourier series to represent function. Note down करा example. Fx is equal to x in the interval minus pi to pi, and f of x is equal to f of x plus 2 pi. This is periodic with period 2 pi. So you have to check whether this function is even or odd, because the interval is minus pi to pi. We know that function is odd. Am I right? So if function is odd in the interval minus pi to pi, then what is the case? See, if the function is odd, here, if the function is odd, see this, then it become half range sine series, and here a naught and a n are 0. If we do have find only dn. dn फक्त find करायचा आहे. It is very simple. येईल solve करता.
sir.
Okay. So for more examples, okay, that's it. This is the end of this lecture. I'll just conclude, but don't leave. I will share the attendance link, record your attendance, and I will show you how to access the notes for this unit. Okay, just a minute. So, sharing.